The U.S. Air Force Research Laboratory, known for spearheading advanced aerospace technologies, has granted a significant contract to General Atomics Aeronautical Systems, Inc. GAAC, a company that has for decades remained at the forefront of unmanned aerial system (UAS) innovation. This contract, valued at over $99 million, is centered on the development of what has been described as a hybrid electric propulsion ducted fan next-generation intelligence, surveillance, reconnaissance, and strike unmanned aerial system. Internally referred to as GHOST, the system signals a serious leap in drone propulsion technology, surveillance reach, and mission flexibility. Unlike conventional UAV propulsion systems that primarily rely on internal combustion or jet propulsion engines alone, this effort focuses on integrating hybrid electric propulsion with ducted fan architecture, combining the benefits of both electric and traditional propulsion methods into a potentially revolutionary system. The hybrid electric design is expected to bring about a range of operational advantages. By combining a heavy fuel internal combustion engine with electric motors and possibly battery packs, the resulting system could enable persistent airborne operations far beyond the endurance of legacy platforms such as the MQ-9 Reaper. This configuration allows for the efficient generation and use of energy, where the combustion engine powers generators that, in turn, supply electricity to motors connected to ducted fans. This kind of setup can reduce the mechanical complexity associated with direct engine-driven propellers, while also increasing energy conversion efficiency. One of the most significant benefits of this approach lies in the expected range and loiter time. The ability to stay airborne for extended periods, potentially up to 60 hours as previously mentioned in connection with General Atomics' Gambit drone family, marks a major strategic enhancement, especially for long-duration intelligence gathering or surveillance missions over vast, remote, or contested areas such as the South China Sea. Equally important is the noise reduction associated with ducted fans, especially when combined with electric propulsion at lower thrust settings. This significantly reduces the acoustic signature of the aircraft, making it more difficult for adversaries to detect and track it via audio or infrared sensors. In high-stakes reconnaissance or first strike ISR operations where stealth is paramount, this reduced detectability becomes a major tactical asset. The quieter propulsion system, paired with a low infrared signature, also opens opportunities for operating at lower altitudes without drawing attention, which could be crucial in contested environments. Furthermore, the use of ducted fans, which enclose the spinning blades within a shroud, improves safety, reduces drag, and allows for better integration into stealthy airframes, like the flying wing configurations favored in stealth design. General Atomics has been developing these ideas over the last several years. Back in 2022, senior leadership within GAAC, including Mike Atwood and Dave Alexander, openly discussed the concept of using a hybrid electric system not just as an efficiency play but as a foundational technology that could redefine what unmanned aircraft are capable of. Atwood described the architecture as akin to merging the electric drive efficiency of a Tesla Model S with the advanced stealth and mission performance of the RQ-170 Sentinel. This analogy, though slightly tongue-in-cheek, hinted at the dramatic change in paradigm, moving from traditional air-breathing propulsion to something fundamentally quieter, longer-lasting, and potentially smarter in energy distribution. The fact that Atwood later became VP of Advanced Programs underlines the strategic importance GAAC places on this propulsion technology. While the Air Force has not publicly disclosed the specific operationalization path for the GHOST project, its placement within the AFRL suggests that it remains in a high-end R&D phase, with completion expected by August 2028. That timeline provides a window for General Atomics to mature the technology, conduct full-scale testing, and potentially integrate lessons from parallel programs such as the Collaborative Combat Aircraft (CCA) initiative. The YFQ-42A, derived from the XQ-67A built under AFRL's Off-Board Sensing Station program, represents one such evolution, where General Atomics has already demonstrated the willingness and capability to evolve conceptual stealth UAVs into viable platforms under the Air Force's future combat architecture. The larger strategic context is also critical. The Air Force has increasingly leaned into distributed, agile concepts such as Agile Combat Employment (ACE), which demand aircraft that can operate from rough, short runways with limited logistical support. For example, General Atomics has explicitly noted that drones built under this new propulsion regime could take off and land from 3,000-foot runways. That dramatically increases the number of potential basing locations, especially in the Indo-Pacific, where fixed bases are vulnerable to missile attacks. If a stealthy, long-endurance drone with quiet propulsion can deploy from austere locations and loiter in contested airspace for several days at a time. It could be used to persistently monitor enemy naval movements, communications, and activity without requiring a full satellite constellation or putting manned aircraft at risk. Moreover, the idea that this platform could also perform strike roles implies not only a sensor-carrying ISR function but also a kinetic capability. That might mean equipping the airframe with precision-guided munitions or loitering munitions for time-sensitive targets. Strike capability would allow the Ghost to respond rapidly to emerging threats or targets of opportunity, something not often associated with endurance-focused ISR drones. The ability to quickly move from sensing to shooting without external direction increases the tactical autonomy and relevance of the platform in modern conflict zones. This ambition also ties directly into the Gambit family of drones. Gambit 4 in particular, which has been shown as a stealthy, flying wing-type drone, is seen as a core element of this modular UAS architecture. All Gambit drones share a central chassis with standardized landing gear and mission systems, allowing for rapid reconfiguration and evolution of designs. Gambit 4's expected role as a persistent ISR platform further echoes the goals laid out for the Ghost project. Interestingly, the propulsion system for Gambit 4 is not derived from earlier heavy fuel engine programs like that of the MQ-1C Block 25. Instead, a separate 8-cylinder diesel engine will be developed to meet the specific hybrid electric requirements of that platform, showing a tailored approach rather than retrofitting old hardware. Even though public disclosures remain limited, it's clear from multiple statements and consistent reporting across industry sources that General Atomics is investing heavily in making hybrid electric propulsion a defining capability of the next generation of uncrewed systems. These systems are envisioned to operate not just in permissive airspace, but in heavily contested environments where low observability, endurance, quiet operation, and rapid adaptability are essential. The Ghost project, with its layered implications for propulsion innovation, stealth design, multi-mission flexibility, and expeditionary operability, appears to be not just a continuation of previous General Atomics UAV evolution, but a calculated leap toward the kind of autonomous air dominance the U.S. Air Force will need in peer conflicts.